Oh my, look at that, we're live. Technical problems abound, but we seem to be online now. Hold on a second, nobody's going to be able to see this until we get a link to it. Any idea where this link is going to come from, Glenn?
I think Daniel should have it. Daniel, do you have it?
Here he is, he's got a link. Okay, we got a link. Link is going in the chat room. Use this link. Okay, so, oh, there you go. Daniel posted it in the chat room too. So we have chat in Crowdcast. We have questions in Crowdcast, but we have no video and no audio in Crowdcast. Apparently, there are some integration problems between the Google On-Air Hangouts and the Crowdcast platform, so technical difficulties have forced us to go directly to the horse's mouth. And this is a Google Hangout on air. Okay, Glenn, let's get started with the good stuff.
Okay. Why don't you read the first question?
Are we going to go in that order, or shall we start with your question?
Well, I'm actually not seeing the questions right now, so I probably need a link to the Crowdcast as well.
Back to the Crowdcast to see the questions. Here, let me give you one of those links in one of our many background channels that we have. There you go. There's the link. Okay, well, we'll start with my question while you're getting that link up. The question is, what is a hop-by-hop header, and why should I care? I like this particularly because I like the sound of a hop-by-hop header. It sounds very interesting, and you don't hear a lot of people talking about it. Is it a term you're familiar with, Glenn?
Not really, actually.
Okay,
so I'm equally curious.
In HTTP, we have headers, right? Headers are part of the message that are sent between the client and the origin server. However, there can be a set of intermediaries that sit between the client and the server, and we don't know how many intermediaries there might be, because we have a layered architecture, and that's how it's all supposed to work. A hop-by-hop header is a special kind of header that is only intended to be transferred from one intermediary to the next. It is not supposed to travel all the way to the backend server. In fact, the rules are is if an intermediary receives a hop-by-hop header, it is supposed to remove it from the message before retransmitting the message along to the next intermediary in the path. So I think probably the most common example that people will see of a hop-by-hop header is either, the connection header is part of this process, and the connection header is used to identify either certain options that are only applicable on hop-by-hop, or it's used to identify other headers that are hop-by-hop. So, for example, if you see connection keep alive, it means the keep alive header is only applicable between this component and the next component or next intermediary, and should not be transferred along to the next one along the wire. Keep alive is very much a HTTP 1.0 thing. Now what we do, because persistence are default, we use connection close, which is what they refer to as an option, a hop-by-hop option, because there is no corresponding close. Another example of a hop-by-hop header would be transfer encoding. The idea of transfer encoding is that you can designate all traffic, all messages that pass between, for example, this client and the proxy, the corporate proxy, or the corporate proxy and the next server are going to be compressed or potentially encrypted or something like that. But transfer encoding only applies between one intermediary and the next, which is different than content encoding, which is part of the payload, and that travels from back to front. But in order to use transfer encoding, you're supposed to put transfer encoding into the connection header so that the next intermediary along knows that, oh, It was transfer encoded, and therefore I should uncompress it, and then remove that connection header.
Yeah, I mean, we kind of jumped right from hop by hop into encoding. I guess I missed the
Well, it was just transfer encoding is one example of one of the headers that is hop by hop. Now, the interesting thing is, if you read RFC 2616, it explicitly goes through and lists a bunch of headers that are considered hop by hop. I have yet to be able to find that same list in the 7230 and 7231. So I'm wondering whether they relaxed that and maybe said, well, maybe transfer encoding doesn't have to be hop by hop. That is still something that is under investigation, because it's in 7230, but as I say, in 7226 they list a whole bunch of headers that are very specifically hop by hop. Now, I mean, the important thing there really is going back to connection control, right? Because we look at things like keep alive, and we kind of perceive it as maintaining a connection open all the way to the back end. But that really isn't the case. Any intermediary along the way could change its mind and say, I know you want to keep a persistent connection open to me, but I'm not going to further down the wire.
Right, and you don't care, technically.
Though
it might have implications. Like you might end up not getting the performance that you would expect to get because of the fact that there actually is a socket that's getting opened and closed somewhere along the chain. Yeah, that's a really good point. So the one I think about a lot with transfer encoding is chunked.
Right.
Like that seems to be like a very common place where transfer encoding hits people. Is when developers or APIs, when they use something like chunked encoding. Do you want to talk a little bit about what chunked encoding is?
Sure. The idea being that if you have large payloads, you may not want to send, you may not want to require that every intermediary along the path holds the entire request or body in memory at one particular point in time. Imagine you're sending over a 1 gig file. You don't want to transfer all of the 1 gig file over to some intermediary, have that buffered, and then send it all over to the next element or the next intermediary in the path. So chunked encoding allows you to send a set of bytes and instead of sending a content length header that says, oh, by the way, I'm going to send you 10,000 bytes. You don't send a content length header at all. You send a body, and then at the end of the set of bytes, is it at the end or the beginning? You would think it must be at the beginning. There's a number that says, following this, there's going to be 25 bytes. And then you read the next 25 bytes, and then you send another chunk and say there's going to be another 50 bytes or whatever is the next size of chunk. The chunks don't have to be the same size. And chunking, it's one of those. It's interesting if you look in the most recent MVC6, they turn on chunked encoding by default. Whereas if you look at older versions of Web API, a lot of the server infrastructure used to buffer things immediately, so everything would come down not chunked encoding, and it was actually hard work to get some things to be chunked encoding. So the infrastructure seems to take care of a lot of chunked encoding scenarios.
Yep. So I think a couple of interesting things about chunked encoding. So first, in terms of your question, the only size that you're required to send with chunked encoding is you send the size of the chunk at the beginning of the chunk. So it's really designed around, you can use it for dynamic scenarios. Also important to mention that it can be bidirectional. I can receive data using chunked encoding, and I can send data using chunked encoding. And often in cases where you don't know how big the overall payload even is going to be, it's not a requirement. So chunked encoding is really built around this idea that you actually don't have to know how big the content is going to be. You just have to know how big the chunk is that I'm going to send is going to be. And for this reason, one of the interesting things is people have used chunked encoding pre-WebSockets as a way of doing that kind of streaming interaction with a server, basically sending chunks, because of the fact that it can go on continually, you can kind of use it in a way to have somewhat more of a real-time experience. We've actually used it within our API for streaming data. So we have cases where you're doing queries against Splunk's API where the results that are getting returned are going to be really, really large. We do support a paging mechanism, but we also actually allow you, and in some cases it's more efficient, to just stream those results back. And the streaming of those results, this is before WebSockets even existed as a protocol, is we use a chunked encoding mechanism. We just keep sending another chunk which has results within. So I think it's one of those things that a lot of people don't know about, that has actually been there from the get-go. Not to say this is a replacement for WebSockets, it's certainly not, and we'll get to why. And when we talk about WebSockets, we should mention a little bit about how this is different, because it's definitely very different.
Well, I'm very curious, because I mean, it's a very simplistic mechanism, right? This idea of streaming and chunking, and it makes sense to me if you have long lists of data, things like CSV files. You've got this giant CSV file. It's really easy to process that one line at a time. It gets a little bit more tricky with like a standard JSON file, because a JSON file will start off with a especially if it starts off with the curly braces. I guess if it starts off with an array structure.
You can have an array that basically never ends. And there are parsers that will handle that. There are JSON parsers, and that is kind of what I believe. So what I think we do is we do bound it within the request itself, so it won't be an array that just goes on forever. So it'll be like mini arrays, essentially, is the way we do it, rather than just an open-ended array, like if you're using JSON. So there are techniques that you can use. But I think you're right, and I think people have used it for more of just a standard kind of comedy kind of mechanism, but it can be a lot more expensive for that. In the cases of where you're streaming data, where it's like, hey, you have this large amount of data that's coming, so you want to get it really efficiently, and you don't want to have to keep opening and closing the connection, which of course Keep Alive can address some of that as well. For those of you that don't, I know we mentioned it a few times, but Keep Alive is a mechanism in HTTP 1.1 which basically tells the server to keep the socket open. So
it's not in 1.1, it's in 1.0. They got rid of it in 1.1.
Really?
Because its connections are persistent by default in 1.1. I've never quite figured out why people continue to send Keep Alive header, because you really don't need to. The argument that I've been given in the past is, oh, but there are intermediaries on the web that still use 1.0, and I think that comes from the story that there are some caches that are 1.1 on the front end, but they talk 1.0 on the back end, because 1.0 can be more efficient in very controlled scenarios.
Right.
But really, all you need in 1.1 is to issue connection close, either from the client side or from the server side when you're done with the connection.
I see. Okay. Well, I stand corrected, and I just went to the spec actually to double check this, and you are correct. Now they are Keep Alive is enabled by default.
Yeah. The only thing that was kind of deprecated is like Keep Alive has some parameters, like how long is something. Well, I guess it doesn't matter if by default it's on. By default it's just on, right? And the thing is, I think originally there was this big concern of servers can't handle too many connections. But now we're in the days of people putting up evented servers that can handle tens of thousands of connections at once. It's really much less of an issue to be able to have persistent connections.
Yep. Okay. Well, thank you for clarifying as far as the difference between Keep Alive and 1.1. So has has the fundamental way that Keep Alive has been implemented changed at all, or it's exactly the same? It's just on by default.
I believe it's just on by default. There's, as far as I understand, the mechanism of persistent connections remains the same. It's just you make a request and it's going to be open. The one thing that I always run into living in the .NET space with HTTP client is the fact that if you use an HTTP client and then you dispose of it immediately, because everybody does because it implements iDisposable, internally HTTP client goes, oh, well, you're done, so you know what, I'm going to go and forcibly close down that connection, which defeats the purpose of having persistent connections, because under the covers it's doing connection pooling and trying to keep connections open so that you can make another request. So, which is going to cause even more confusion in the future where they introduce the new internals for HTTP client, which doesn't have the same behavior. So that should all be fun.
On that comment, as far as folks that are using HTTP client or HTTP clients in general, so what you're saying is you actually do have to think about Keep Alive when you're at the client level.
Well, you shouldn't have to.
But you often do today. You have to
the implementation details leak through sometimes.
Yeah. Is there an easy way to work around that, or is it?
I think it comes down to the fact that we should use abstractions to make our lives easier, but you can't ignore the fact that there's real stuff going on behind the scenes, and you should know how to use tools like Fiddler and Charles Proxy and Wireshark and these kind of things, so that when you're doing real performance checks on your systems, that you go and look and actually see what really is happening under the covers. Yeah. And when you're making 100 requests to the same server within a short space of time, make sure that you're reusing the same connection.
Which in this case for the .NET HTTP client would mean don't call dispose.
Yeah.
Don't get rid of. Keep that instance around and just keep reusing it.
Yeah.
Okay, that's great. I have a suggestion that we jump over the next one to go to the WebSockets one, just because we already brought up kind of the topic.
Sure, absolutely.
Yeah. And of course, this one has had a lot of debate and dogma around it.
Well, let's just go back a little bit to long polling, because we talked about this idea of using HTTP and chunked encoding in order to pull down large quantities of data. But there's another use of holding that connection open, and that's to kind of simulate server-initiated activities, right?
Yep. But that's like server push is kind of the big one, wanting to be able to have the server push down information. But the way it's implemented when you're doing something like Comet is very different than, although you could use chunked encoding, you could combine it, it's not a requirement.
Explain to me what you could combine what and what.
Well, chunked when you build like a long polling type server, that's a hanging request.
Right.
Essentially, the request stays open for a period of time, and then it returns a response. When it returns a response, it's going to return a response, and it's going to close after a certain period of time, and then it's going to reopen. That's kind of the long polling kind of mechanism. And if anything happens that's interesting within the time period that the request has that the request is still open, then it will actually just return that data. And so my point was that response, it's a standard HTTP response. There's technically no reason why you couldn't combine those two. Maybe it wouldn't make sense to. Like you could basically say that it returns me a chunked response up to a certain period, and then it kills the response. I don't know that it would make sense to do that.
I see. Okay, so there's on the one scenario we have the hanging response which says, "Go give me something, and I'll wait forever and ever and ever until you give it to me."
Or you time out. I'll wait until you give it to me, or you time out.
Right. So then, once I've received that information, I say, okay, I've got the event from the server. Now I'm going to start another request to the server waiting for the next event. So really the response from the server is a single chunk of information.
Exactly.
Whereas with a chunked encoding, you could end up holding the connection open for a long period of time and get multiple chunks over that period of time. Okay, I got you. I
Yes,
understand.
that was my point. That
Right.
was my point. So the big difference, I would say, between doing something like WebSockets and using the long polling approach really requires just taking a look at what is different about WebSockets in the first place. And the main thing that's different about WebSockets is the framing. So when I'm doing long poll requests, or even if I'm doing so every single time I'm doing a request, there's a lot of headers and a lot of stuff that is going on. Um, and the idea of WebSockets is you actually do like this upgrade. You actually do perform what's called an upgrade. And a lot of that miscellaneous, that extra stuff, which is important when you're not in a real-time communication model, when you're in a you're in a traditional request response model, drops away. And so the framing is the big thing that's different about WebSockets. Is a lot of those headers and things are not there as part of the continual communication once the connection is established.
Okay, but so as an application developer, you're saying the framing is different, but is that kind of like a plumbing issue that I just don't have to worry about at all? It's just bytes going over the wire from an application perspective?
It is a plumbing issue, but it results in things like improved performance.
Okay, so it's a performance benefit. So I could naively basically say I can use WebSockets more efficiently and get a more efficient two-way interaction than just using plain old HTTP long polling.
Right, and because with long polling, I actually am disconnecting at some point. If a period of time goes
Right.
on, the connection's going to get killed. It's going to have to reestablish that connection with the server. So WebSockets, why the socket term there is it acts really more like a socket, which is a persistent connection between the client and the server, and you're not having that period of timeout where suddenly the connection just dies. Once you start that connection with the WebSocket, the idea is that barring, excuse me, barring any kind of technical issue that will happen, which certainly does happen, for all intents and purposes, it will keep that persistent conversation going on.
But it's a WebSocket as opposed to a regular socket, because as I understand, a regular socket will only communicate between two machines.
Yes.
Whereas WebSockets keep this notion of having any number of arbitrary intermediaries.
And that's where in the past there have been problems because of the fact that there were intermediaries, any intermediary, like your example that you gave before, any intermediary along the path that doesn't understand WebSockets, that can actually create a serious problem if the server that it's talking to is expecting that it's a WebSocket communication.
Right, which is exactly why HTTP2 has moved to purely an SSL model, because by doing that, by moving to the SSL model, you basically limit the amount of problems intermediaries can cause, because they just look at it and go, oh yes, it's a secure SSL thing. I'm not going to touch it, right?
Yeah.
And as soon as you go plain old text, the intermediaries go, oh, there's something going on here, and they think they understand, and they don't notice, oh, this is HTTP2, by the way, not HTTP 1.1, and they make a mess of it.
And that's one of the, I think, criticisms that people have given around WebSockets in general, is like the web was designed all around this notion of transparency and, the ability for intermediaries to act on behalf. And when, for all intents and purposes, I mean, it's just like when you use something like SOAP, like that WebSocket is really opaque in terms of what is going on. So there are pros and cons to that kind of model. Where you really see it taking off is as browser applications have become richer and richer and acting more like desktop clients, this need for this rich experience, which involves the server continually pushing information to the client. Like imagine, I'm editing an issue in GitHub, somebody suddenly closes it. That kind of notification model where the server is now going to tell me, hey, this thing is closed now. Although it can be done with long polling, that kind of communication pattern is a lot more efficient when you're doing it with something like WebSockets.
It's more efficient in what term? Like it's more efficient for who? Because obviously the server's got to
The
keep track
server,
of
well,
all these clients.
it's a
The
good
server's
point.
got to do more work, right?
Yes, that's a really good point. So from a server perspective, using WebSockets, one big downside of it is that the server actually has to keep track of all the clients that are connected, which is pushing more burden because each client connection takes up memory and a bunch of other stuff. So that's a really good point. It's not for free.
Right.
Um,
Which is what I like the whole notion of decentralized push notification mechanisms that exist in mobile operating systems, where instead of every single application creating this two-way channel, you route notifications through some central service, and then the OS only has to talk to one push notification server, and so
sure.
it only has to keep that connection open with one server, and everybody can go route via that central broker.
And that's what services like Pusher push on is basically saying, hey, like we'll be that central hub that the clients can connect to and that handles all the WebSocket communication. And then there's multiple different ways for that information to get in to us, which doesn't have to be a WebSocket.
Right.
So yeah, that's why these services have kind of risen in adoption.
Yeah, but I mean, we don't usually get into the whole marketing side of things. But I'm curious from your opinion. Do we need more than one centralized push notification than one per operating system? I mean, Apple have push notifications, Windows have them,
Well,
Google
push
have them.
notifications are a little bit different than the kind of things you'd be doing with WebSockets. Push,
Just because of the frequency of the pushes back,
well, like
or
chat,
the speed.
like a real. I
Okay,
mean,
chat. Okay, yep. That's another great scenario.
I mean, some do try to do chat through notifications, but it's not really efficient way to go.
Okay,
Right?
so now the scenario is low latency.
Yes, low
Two-way.
latency bidirectional communication is where I think WebSockets is interesting.
Right.
But the other thing is, though, if you talk about what you're saying with mobile devices, not everything is via mobile device, even though there's a lot that still is. Now, you do have notification systems now on, like
On
Windows
desktop.
8 has the Windows notifications. So there are mechanisms there, but yeah, it's not black and white. But yeah.
So two-way low latency chat type systems, right? Okay, so why aren't we using XMPP for that stuff?
It's a good question.
I'm throwing it out there, right? That protocol was designed specifically. Is it really just a case of XMPP doesn't like going over port 80 and it's the administrators that are holding the keys to the firewall? Is that, or does it go over port 80?
Well, I think it's also that WebSockets is baked into the HTTP spec now. I mean, that has, it is. HTML. Sorry, HTML
Okay.
browsers have. Sorry, not HTTP. Take that back. Somebody. Fortunately, we have a low following right now, so the number of people that I cause say what, it's pretty low right now. But yeah, no. What I mean is HTML has added support in browsers for WebSockets, so I think that has a lot to do with it. That it's just path of least resistance.
So then, if I am not writing a browser app, I'm writing a mobile app, or I'm writing a full desktop app, are there client libraries that allow me to do WebSockety stuff directly from non-browser clients, or do I just then say go to XMPP?
No, there are clients, and you have servers like Socket.io that I think they've done some work around some native clients. So there are clients that support it, because then it also goes to, well, I know this, why do I have to learn something new? Why does my server have to support multiple protocols when it can support just one? I mean, that's worked pretty well with HTTP. So I think there's that argument.
Oh, okay, so let's look down at the application level for a moment insofar as
The
WebSockets,
port
right?
the port 80 one I think is an important point too.
Right, right.
Um,
It,
the
so,
fact that it just works, right? That I don't have to. I mean, as long as all the servers and everybody in between understand the WebSockets protocol, it's going to work over port
okay.
80.
As an HTTP guy, one of the things that I really like about HTTP is when I want to make a request to a server or get a response, it has a set of conventions and there's certain methods that I'm allowed to use. There's a distinction between metadata and a
Sure.
body. Like there's some organization to
Yep.
my message there.
Yep.
Now, what am I correct in saying that if I want to send a message over WebSockets, I have a blank canvas. I can do anything that I want, right?
And that would be, I would say, would be the for some a pro, and others might say that's a con. Yes, it is a wild. It's pretty much Wild West. I mean, there are some things that have grown on top of WebSockets, like Socket.io is an example that provides its own kind of level of framing on top of WebSockets itself, adds notions of things like channels and rooms and other kinds of things. But yes, pretty much, you're right.
Yeah, because I mean that's one of the challenges, right? When people are building distributed systems, and like if I was getting into a realm of trying to do duplex communication, like this is an area that I really haven't done a lot of work in. And if I was doing
Yep.
something very, very simplistic, I could probably hack it together. But if I want to build a bigger system, it would be nice to be able to build on the experience of others with regards to building full duplex type of communications and like how should a message be structured, what is the best way of communicating the intent of a message,
Yep. Yep.
what formats work, what, like should I use a binary format, should I use a plain text format, like there's so many questions abound.
Yeah, and from what I've seen there, a lot of that work today is being done by library authors. I think a lot of folks that are using WebSockets are doing it through a library, and some of those libraries are just very close to the metal of WebSockets. Like
Right.
in Node, there's like the WS Node mod. There's a bunch of different Node modules that are just using Node as an example. And then there are higher level abstractions. And if you look at things like SignalR and Socket.io, that are also trying to give you the benefit of choice and saying, hey, these are pluggable. So if you want to plug in support for other kinds of clients, you can. So yeah, it's a good question. I think this is still. I mean, WebSockets is still relatively new in terms of years, and it's I don't think it replaces. There are some people that are exploring the idea of using a WebSocket for your entire API, but I think what's more common is going to be a hybrid, where you
Right.
have an API and then you have some aspects of information, and maybe you do both. Like I relate this back to kind of the Splunk world. It's very common for us that we support kind of push scenarios where data is getting pushed in. It's coming in a real-time feed, but that doesn't give you access to historical information. So to get the historical information, you need some type of APIs to poll against. So that's just a simple example. So I think the hybrid cases are fine, and that's probably going to be the more prominent way that at least it's the way I've seen up to now WebSockets played out in the wild, is that there's a standard API and then there's some portion of the content that the server returns that can then be available through something like WebSockets.
Yeah. Yeah. So we've talked about WebSockets as like trying to you said about it being a hybrid. So let's see if we can identify the scenarios where maybe you'd go for one versus the other. We have the obviously the real-time chat is classic, right?
Yeah,
if you're trying to do some kind of online game where you need really low latency, both input in both and direct feedback.
Yeah, take a stock ticker. That's another great example that people use WebSockets for, where it's a continual stream of stock quotes that is running.
Right, but that's really one direction, right?
That is one
That's
direction, but
from server.
I don't think it has to be. It does not have to be bidirectional. It's the
Right, but
persistent.
why is polling that not just as an efficient a route?
Well, the framing, right? The framing. And once I've created talk, the framing is the big thing that makes the difference. If you talk about stock quotes coming in at high volume, there's going to be a significant difference in the payload size when I'm getting, just the quotes.
Right.
Once I've upgraded.
Okay, but if I use chunked encoding for that, right, then all I would get is just the bytes coming over the wire, right?
Yeah, I guess that's true. I would establish the request and then I would get back the chunked encoding. Um, so
And
yeah,
then
go ahead.
and then if we look at the potential for HTTP2 with the header compression capabilities, where if you're retrieving the same request multiple times,
Yeah.
the headers are going to be almost identical, and therefore many of the headers will come over in a completely compressed form, therefore minimizing. Basically all you need is content length.
No,
Media type.
it's a great point, and I've heard some folks. I think even Guillermo Roach, who wrote Socket.io, was saying that with HTTP2, the need for WebSockets becomes a lot less for those reasons.
Yeah.
So yeah, but of course, that's still happening. But yeah.
But again, comes back to hybrid. Choose the best tool for the job. I realize that's a cliche, but
but I think we could set
engineering and picking the least worst solution for every problem.
Exactly, and I think the important point is that what we choose today is not what we'll choose tomorrow. Like, that's just a fact of life. Like, we're having a conversation about what would somebody do today.
Yeah.
We could probably revisit this conversation as HTTP 2.0 gains a lot more traction and as real-world examples emerge of people trying to do this stuff. Anyway, great conversation on WebSockets.
Yes, I learned a lot. Appreciate it.
Cool. Let's move on to the next one. Home resource.
Time for another question?
Yeah.
Do we want to go for that, or should we move on to your question about media types?
Whichever one you prefer. I will let you choose.
Okay, well, we can do the My Home resource a lot quicker because the media types opens up a whole realm of conversations. The idea in the question is basically, is it a good idea to have a kind of /home/my page type of resource in an API where the result is different depending on who is the authenticated user?
Yes.
And it's nice. It's a nice resource insofar as it makes it easy to communicate with somebody. Insofar as just log into there and just hit the /home resource and you'll see all the information related to you. You don't have to worry about going /user/some arbitrary ID /home. So it makes it very easy to discover that particular resource. The downside of it is out of the box is you can't cache it. You can't cache the responses to it in a public cache because then people would get other people's homepage, which obviously you don't want to have happen. Usually, if you have an authorization header, and unless specifically said it can happen, public caches won't cache responses that have an authorization header in, so it shouldn't get cached. And there is no reason why it could not be cached in a local cache. So the only downside to it that I see is if you actually wanted to share your home page with somebody else. You copy paste the link from your browser and you paste it into an email and you email it to somebody. When they click on it, they're not seeing the same thing that you're seeing. So
Yep.
A lot of it depends on the type of application that you're building, I think. Sometimes it makes sense, sometimes it doesn't. Again, it's just worth knowing what the pros and cons are for that type of resource.
This is a recurring theme.
Yes. There are no easy answers. We have to think and just understand the basic rules and remember the constraints of REST insofar as caching and layering and what the impacts are on the choices that you make. And then make a decision.
One thing I thought was interesting is you talked about the authorization header being the mechanism. I think, though, one other way that people do this is they rely on the session state.
Better say large or wide open there. Let me drive a truck through it.
Pressing some buttons. But
okay, fair enough. Again, what did I said? You make decisions based on what are the constraints of HTTP, REST, blah, blah, blah. And one of those constraints is called things should be stateless.
Stateless, yes.
Now, stateless doesn't mean that we have no state, which is just the wonderful thing. You can have resource state, i.e. there are things on the server that we can store and that are permanent. Right. We can have client state. So that depending on where we've been previously, we might choose to go to different places. But the idea is that when you make a request,
everything you need is in the request.
Everything you need is in the request. You shouldn't have to make two. If you make two particular requests in order, especially if they're both safe requests, they should always give exactly the same results. And you should be able to get rid of the first one and the second one still give you the same results.
Right.
When you introduce session state, you introduce hidden state that is not visible to the client because it can't go and retrieve it, and you affect the output of potentially that second request because of some hidden state. Now, the canonical example of this is the notion of logging in to a server. And this whole notion of, oh, I'm logged in and I'm logged out is actually really counter to the whole concept of the web. You're not supposed to have like a logged in state versus a logged out state.
Right.
And the fact that different things happen when you are logged in versus logged out is actually technically not a good thing to do. However, if you implement HTTP requests and API calls as intended, you pass the authentication information along with every request.
Right.
Therefore, if you weren't logged in before, using that term that I really shouldn't use, then when you make the request, you provide all the necessary credentials for the system to say, oh, yes, this is who the person is. You are authenticated, therefore I will return you back. So the whole logged in and logged out is a bit of an illusion, or if it's done right, is a little bit of an illusion.
Great. What do you think about the idea of kind of a hybrid approach of having like a home resource with a redirect that takes you, or could you, I guess you couldn't, it wouldn't be a content location header, it would be a pure redirect that would take you to the fully qualified resource.
Yep, you could redirect. That gives us the simplicity notion. It puts it a bit weird with regards to sharing the URL, because the person is still going to get redirected to their homepage, not your homepage. So you're not exactly sharing what maybe you thought you were sharing. You get a lot of people who are very upset about that whole idea of redirect because they immediately go, "Oh, the performance is terrible. I don't want to do that."
Point.
And although I'm 100% in agreement that you have to be really careful how many round trips you make, and using redirect aren't good. Sorry, I shouldn't say they aren't good. They have a cost associated to them. But we have to put these things in perspective. Like, the most successful use of the web is web browsers. And when you go and visit the average page now, you make like 50, 60, 70 requests. And I regularly see people who say, oh, I browsed to this web page and it made 5 redirects before it actually got to the web page. So as long as we don't get there, I think having one redirect, as long as it's not a really performance-sensitive request, is probably not a major performance issue for your API.
And could caching help you there, or probably not in this case, because the data might change on the home resource? So, couldn't you use e-tags there to help?
Well, not even e-tags. There's absolutely no reason why you cannot cache the redirect response.
Yeah.
So,
sure.
The assumption being, let's see how that would work.
So you would still make the request, you would get back the redirect, and then instead of you wouldn't have to go back to the server if you had it cached.
Well, for either the initial request that returned the redirect or the one that actually returned your actual home page, because and the thing is, how long can you cache that redirect for? Well, if you use an ID for the user that cannot change, let's say you use a GUID for the ID, in theory, the redirect, you could cache that forever, right? And it's valid until it gets pushed out of the cache because there's too much stuff in the cache,
so you would
or
never
it expires.
So you would never have to hit the server for that one.
For that redirect.
After the first time, you would never have to hit it again. You would always know to go directly. I see. Well, that's one of the beauties of those are the kind of things that when we talk about the WebSockets discussion, that some of those benefits get lost.
Yeah. Well, some of those benefits get lost too because, I don't think there are very many very effective client-side caches, and a lot of people don't use client-side caches, and they're not enabled, and they don't consider them. So there's much potential.
But take the case of if I tried to put a full API as a WebSocket API, so I created some type of protocol on top, that allowed me to specify the kind of requests for certain resources, and they all come back through the WebSocket. I'm losing all of the benefit that the web will provide me on being able to say, oh, well, this request quote that you're making within the WebSocket is actually something that some other server over here has that it can just give you. You have to go all the way back to the origin server.
Yeah. You can forget about CDNs. You can forget about all of those optimizations that exist on the web for performance, because absolutely everything you do has to go all the way back to that origin server, and the origin server has to deal with it and send it you all the way back. So it's a big cost that you're paying if you decide to go 100% WebSockets, which is why the hybrid approach makes more sense.
Cool. All right. Well, with that, I think we've
flogged that horse.
And I think we've reached the end of our episode.
Indeed. Hopefully next week we can, or 2 weeks' time, we will have our technical difficulties sorted out, and hopefully I will have got round to actually making all these episodes available as podcasts, so people can subscribe to them and not have to be around at exactly the time that we are around.
Okay, well, thank you everyone for joining us, and for those of you that celebrated the recent holiday, we hope you had a good holiday, and we'll see you in 2 weeks.
Thank you very much.